So today we'll be on the chapter 2, part 2, okay, the operators. Part 1, we on data type. So chapter 2 still on the data, but we have the two part, okay. First part, the most important part is the successive division algorithm, okay. And now we look on the operators. Okay, so we will go through the basic program structures, and then we will go over the operators. So program units, okay. The largest program unit is package, okay. And package, you seldom see it, but when you say Java that UTIL, this UTIL by itself is a package. Inside the package, there are many classes. So package is a collection of the classes. It's like a library, or maybe like a book. And then class is a chapter, okay? Class is a chapter, so basically. So you can also make your program, a whole program of multiple classes, a package, okay? You can do that. Later, when we are in chapter 9, I'll teach you how to make a jar file, okay? It's called Java archive file. Okay, Java archive file, jar. In chapter 9, if we have time, we'll cover it, okay? So that's about how to make a package. Then we have class. Class is a smallest program unit we have in the program, okay? A single program that can run, the smallest unit is a class. Then we have function or method that actually is a paragraph, okay? Statement is one action. When you do one thing, one single action, we call it a statement. It finished by a semicolon, okay? Then the next one is expression. Expression, you give you some value. Anything give you some value, that it's a expression. Available is an expression. Available plus something is another expression. A function is an expression. A function plus something that give you a certain value still is an expression. So expression that will give you some value. Okay, usually you have a right-hand side expression or left-hand side expression. In Java, the left-hand side expression can only be available. You cannot put a function f of something equals 3. That's not okay. But in C++, it may okay. Okay, C++ may okay. But left-hand side, you can only put some variable. Right-hand side, you get some expression. Expression, you get some value, then you can assign it to the left-hand side. Okay, that's the expression. And the variable is a single data storage. We call it variable. Okay, so these are the basic program structures. We'll cover it, and then we'll talk about the operator and combination of the things. Okay. Okay, so basic program unit. I think this one we covered it in the pre-AP part. So Java the UTIL is a package, scanning is a class, next integer is a method statement. This finish with a semicolon, that's a statement, okay? And hour times 60, that give you a value, that's an expression. Token is a single word. So token usually is a operator or a variable or a function or a class or a reserved word. That's called token. Okay, anyway, these are the program structures. So this portion, I'm not going to repeat it. Okay, these are easy, so I'll just let it through. I think everyone here know it. Cobra. Cobra is starting curly brace, ending with another curly brace. This is Cobra. Cobra has two purposes. One is a collection of many statements. Now we call it a Cobra. Second one is that it forms a domain. It forms a domain. It forms a domain. So some variable defined in the Cobra, we call it local variable. And local variable will be stored in the stack. When you put the data in, it will be stored in the stack. So a Cobra forms a domain for the variable. Outside this Cobra, this variable will not be recognized, okay? Because your code frame doesn't cover it, okay? So that's the purpose of the Cobra. So Cobra start with curly brace, curly brace. Single statement don't need to have the curly brace, curly brace. Okay, that's the Cobra. Okay, I'm not going to spend this too much time. These are basic program structures. Next one is static program versus object-oriented programs. Okay, these two I'm going to use example to tell you what they are. Okay. So let's assume that we actually use the example that we have over here. Okay, class physics. Okay, this is a class. So let's write a class purely in this class purely in static program. Okay, so you have a public static, okay, volume, okay, string data bracket args, okay, like this. Okay, we would like to define something called charge. Okay, so charge. Let's actually look at the force. You have electronic, okay? You have the positive particle and negative charge particle, okay? And there are certain distance r, okay? And they will be a force. Actually attracting each other, there's a force. So this force would be equal to a constant times, a constant times, that's constant that use K, okay? K. Take K times Q1, Q2 divided by R squared. Okay, this would be the force for two charge. Okay, that's actually the equation for physics. Okay, so these are the, let's look at the Google. Okay, this one called charge force equation formula. Okay, so this is the formula. Okay, let me copy this one. No matter it's expelling charge force or the attracting force, it should be F equals K Q1 Q2 over R squared. Okay, over R squared. This one is called charge. Okay, let's look at it. The K is called a Coulomb constant. K is called Coulomb constant. Okay, there's a constant, and then this defines the charge force for you. Okay, so let's look at this portion. F will be equal to Q1Q divided by R squared. So basically, the farther, if you two charge going far further away, R increase, the force would drop more. Okay, and the Coulomb constant is 8.99 times 10 to the power 9. Okay, this is a unit. We don't care about a unit too much. Okay, so that's assume this is the equation we want to use. It's called Coulomb's law. Okay, to measure the force for two charge. Okay, Q1, Q2 is by the electricity level of the Coulomb. Okay, so let's assume that we do have double Q1. Okay, Q1 equals 1. Okay, we also have the Q2 also equals 1. Okay, and then we need to have a constant. So let's do this. Let's have the final stated. Okay, double constant K. K would be 8.99 E9. Okay, this one is to tell you it is 8.99 times 10 to the power 9. Okay, this is the constant K. Okay, the constant K. So we do have the charge 2. We do have this one charge 2. Let's assume these are all 1 Coulomb. Okay, 1 Coulomb. Okay, 1 Coulomb. Okay, and then the force double F will be equal to K times Q1 times Q2 divided by R squared. So let's do mass power R squared. Okay. Now we don't have R, so let's do double R, whose this one should be in meter. Okay, in meter, but we want it to be, let's assume that it's nanometer. So let's do 1 raised to the power minus 9. That's 1 nanometer. Okay. So 1 nanometer. Okay, that's the power, that's the force we can have. Okay. And this force unit is in Newton. How many Newton? Okay, so let's do system that out the print line, print F. Okay, the electrical force is percentage 0.4 F. Okay, newtons /N, and then that will be F. Okay, I'm just showing you to write a program using the static function, right? So it'll give you something here, okay, some Newton. Okay, you don't like to use this F format because this number not good. Okay, so that's E format is scientific notation. Okay, so it'll give you 8.99 something Newton. Is that okay? Is that okay?
Yes.
So this power actually really big, okay, because it's actually within 1 nanometer. That's pretty short, very, very short. So the electricity actually is pretty, the force actually pretty high, okay. So this one, we have a static function. We write it in this way, but sometimes we can define a function. So public, okay, double force. Okay, so here I use a static function. So you can call this a static function. Give me the double Q1, double Q2, and then double R. Okay, we need these 3 numbers, right? Constant is the same. So this one we would actually cut this one, put it over here. Okay, and we directly do return. Okay, there's a function, we return that, and then we actually get this force, put it over here. Okay, this one you put in Q1 and Q2 and R. This one, this example, what I want to show you is actually a static function. Okay, static function calling static function. So this program structure, you go from here, go to this force, come to here, calculate it, finish, come back. Okay, so that's called, you have a main program, and then go to the force calculation function, finish, come back, and then return value to F, and then continue. Okay, so this is the main program. This one is a force function. Okay, I'm showing you this is regular static program flow. Okay, so that is a regular program flow. Okay, you can do it. Now let's try another one. I'm going to show you, this is a typical static function, called it static function way of writing program. We call it static program. There's another type of function, we call it object-oriented program. Okay, so object-oriented program, let's use object underline physics. Okay, so this one is object type of physics. Now, let's don't call it object. No, let's don't call it object for actually physics. Okay, let's call it charge. Okay, I do have a charge. I'm sorry. I do have a charge. This actually is an electrical particle that comes with a charge. Okay, so this charge which would have certain electrical quantity. We call it Q. Okay, Q. Okay, so this one is the instance variable. Okay, there's no static. Okay, so this is a charge. It has one property that is its charge. It's a charge. How much electricity it has is this amount, Q amount column. Okay. Now you need to build a constructor. So we do charge. Okay. And then we have a double QQ. If you want to use the same name, you have to use this Q equals Q. Okay. If you use the same variable name, then this variable Q will be assigned to this Q. The blue Q will assign to the red Q. This Q is red Q, okay? And then the right-hand side Q is the blue Q. Okay, they are different. But if you actually use a different name, then you don't need to have this, okay? Then you don't need to have this. The QQ is the blue one, Q is the red one. So far, okay? Hi, Michael, are you okay?
Yeah.
This one in Python, we also cover it, okay, for the class design. Okay, this one we call it constructor.
Okay.
In Python, it actually is called underline init function. Okay.
Okay.
Leon, are you okay?
Yeah, I'm fine.
Okay, right here, I'm going to keep to use the same queue, okay, but I want to use this queue format, okay? This just calling current object. In Python, this is using self, okay? But anyway, this one build a charge with this much, okay? Then I would like to get the electrical field. So let's do public, okay? Double get field. Get, okay, let's do get. Now let me explain this one. Some of you are going to take the AP Physics AP Physics 2, okay? So this electric field is equal to K times Q1 divided by R squared, okay? F actually equals to K Q1 Q2 divided by R squared, okay? So F is equal to Q2 times E. So what does this mean by this E? E means that there is a certain particle of different distance, a unit charge will get certain amount of force. So if your charge is bigger, you get bigger force. But the original Q1 will give you the field strength, E, okay? Will give you the field strength, E. So we use this one to describe how much force power your electrical charge would get, okay? Okay, anyway, I try to use this one just to give you an example of how a object-oriented program can be used in physics, okay? So here we actually will get your Q already there, so you're going to return, okay? The K times, okay, constant K need to be here, so let's do final static, okay, K double K equals 8.99 okay, that's the Coulomb constant. So K will times your current Q, okay, divided by the R. So R is the distance from the charge. So R needed, okay. And right here, you still need to divide it by mass dot power of the R squared. Okay, so that's getting the electrical field by the R, okay? And then you may have a public string, okay, toString. Now convert this class to a string, okay? Convert this object to a string. We cover this in chapter 10 of the pre-AP, okay? So this toString function in Python is underline str function, okay? So this one you return, okay, and then string the format. String the format is similar to printf, okay. So here you have the charge Q of a certain amount. Let's put in the 0.2f, okay, at 0.2e, okay, using e, okay. And then this one also percentage 0.4 e, okay, because the number can be big, can be small. So right here, let's put the Q and the force and the electrical field, okay. And let me see. No, this is only charge, so we don't need the field. Let's just print out the charge amount, okay? Just print out the charge amount. Okay, good. This one is a basic class, okay? Now, I'm going to write a test charge. Let me write it as object underline physics, okay? So I'm going to actually get the same, everything the same. Just copy the main program, okay, over. Okay, so I'm going to delete everything here. So now this Q1 we have that, okay, Q2 we have that. So we are going to do charge, okay, C1 equal to new charge, using the Q1 to create a new charge, okay. R we have it, so the force would be equal to Q2 times charge 1 that get E with R, okay. You get the same result. So what I want to say is the second way is object-oriented program, okay? The second way is the object-oriented program. First way is the pure static function, calling static function. Second one is a object-oriented way. You create a object and then use the object's instance function to calculate it. You don't understand it right now, okay? I will, in the future, I still talk about object-oriented programming, but right here, just to teach you two major program style. Number one is a simple function calling function, and you always put static there. It's static function calling static function. Second one is that you define the charge as a class, and then you do programming based on the class. So that charge is a positive charge particle, and you calculate the electrical field and use the electrical field to calculate your force. Okay, either way work. Okay, either way work. But in AP level, especially the second semester, our focus will be on here. Okay, in pre-AP, we touch just one chapter, chapter 10, very little of it. But in AP, the second semester, we are purely on this one. Very heavy on this portion, okay? And we study this major purpose is to do GUI, graphic design, and developing larger programs, okay? Is that okay so far? Is that okay so far?
Yeah.
And one more thing is like, okay, we define an object, we define a class, and in fact, the charge is also a data type. So Sarah, what kind of data type this one is?
Double.
No. Charge is not double. Charge is charge type, is reference type. So what is the difference between reference type and primitive data type?
Like it's like pointing to the address and it's not like directly holding the value.
Yes. So you do C1 holding the address, but it pointing to somewhere have the quantity of the charge there in the heap, right? So if you do primitive, you do double holding the charge by itself. Is that okay?
Yeah.
So that's the main difference. This one, Leon, are you okay?
Yeah.
Primitive data type, like a double integer, a char, or boolean, holding the value on the memory location by itself. Reference type like string or object or array, they don't hold the data because their data size can be different. It's not one single character. It may be 20 character, maybe 8 character, maybe 20 integer, maybe 2 integer, maybe no integer. So the reference data type only holding the address. If they don't hold address, sometimes they just got assigned by null. Okay, so that's the major difference between reference type and primitive type. Okay. The next one. Michael, are you okay?
Yeah. What's like cold nanometer and stuff like that?
Nanometer is 10 to the power minus 9. We call it nanometer.
Oh, okay.
So when you do, why are we calculating this? Sometimes we do calculate the NPN. This is actually one transistor. Okay, one transistor. You talk about the IC, right? Sometimes we talk about the IC. The IC has a transistor, so here you have a top plate. This is a metal plate, okay? Usually a metal plate. And we call this one semiconductor because usually this is the current cannot fall through, okay? Cannot fall through. But if right here you apply a positive charge, then some negative charge will be attracted here. Then if you actually create a tunnel so electron can flow through. And this actually depending on how far it is, that's the R, right? That's the distance of the top plate and bottom plate. There's an R, so you can eject the electron. When you eject the electron, then the electron can flow from here to here, creating the current. Okay, so because the transistor is pretty small, so right now this already in the nanometer range. For example, we say 5 nanometer Apple A14 processor, right? 5 nanometer Apple processor. It's built with a transistor, the channel length right here, we call it lambda, only 5 nanometer. Channel length usually is 2 lambda equals 5 nanometer. Then we call it 5 nanometer transistor. 1 nanometer is 10 to the power minus 9. So the transistor is extremely small. Okay. And our AI chip try to be even smaller. Okay. That's why people are competing for a TSMC for a smaller transistor. So let's look at A17 3 nanometer. Okay, something that is you search for Apple's A17. They are going to go for the 3 nanometer transistor. We are calculating something like this right now. Okay, is that okay? We are calculating something like the charge, how much force can be created between these two plates, so that you can extract how much electron, so the current can go through. So it become a switch. When you apply high voltage to it, it got connected. If you have a low voltage, no, you'll be open. So that become a switch. You can use the top plate to control whether the current should fall through or don't go through. Is that okay? Okay, this is also computer science. Okay, I'm teaching you electronics. It's very important. Okay, Right now, AI is competing for the deep nanometer technology. Any question? Sherry, are you okay?
Yeah.
Okay. Make sure you understand, okay? Key point right here, I'm talking about semiconductor as an example, but key point is you need to understand what is static function, call it static function. The other one is you create a object class type called charge. You can use that to create data of the charge type, and then use that to do the same computation you have in this static function. So this physics, we call it structural programming. Structured programming. Sarah, what is structured programming?
I don't remember.
You don't remember? Structured programming is that you only use if, for loop, while loop, and the function. So basically, you can draw by flowchart. Anything can draw by flowchart. It's called structured programming. Is that okay?
Yeah.
And this object physics, we use it as an object-oriented programming. That means you create a charge object. This one has some function you can use. And then when we use it, create a charge. And then apply a Q2 to calculate a force. That's called object-oriented programming. These two programming paradigms totally different. Okay, so this we call it programming paradigm. This kind of a thing we call it programming paradigm. So what kind of programming paradigm we have? We have the structural programming. We do have this one called object-oriented programming. And in fact, you learn Java in AP just because you want to learn OOP, object-oriented programming. And this one, Java is the best language. Object-oriented programming, OOP. Okay? Structural programming, you do C, C++, you all have that. C++ also have object, but C++ object is very difficult to use. And then next one, we still have another new term called functional programming. Okay, this one actually Python is very good on this one. Okay, Python is better than Java. So that's why AI always use this. Okay, but this course, we are not touching AI. Okay, but you learn Python, you will learn this, but you don't get too much of the functional programming in high school or Python. Okay, you have to take Berkeley CS61A, they will teach you what is functional programming, okay? But right here, AP is touching this one and this one. So first semester, we are purely on structural programming. If then else while loop and array and two-dimensional array list. That's called structural programming. Second semester, we focus on object-oriented programming, object, member function, instant function, static function, and then inheritance, dynamic binding, and also the polymorphism. Okay, so it's totally different programming paradigm, and we don't teach you functional programming. Functional programming, if we have time, we may open another course called Python 2 or 3 with teaching. Okay, it's more typical courses. But here you need to build things up step by step, okay? If you want to learn AI, you need to learn Python, okay? But right here, we are focused on GUI and graphic design and object-oriented programming in Java, okay? But here, I just try to teach you the different programming paradigm. So not only you need to learn the language, but you also need to learn the different paradigms in different languages. Okay, or one more paradigm. Okay, one more paradigm. One more paradigm is not following any one of these. It's using neural network. Okay, neural network is totally different paradigms. Okay, that's for AI. But again, this one is too much right now. We don't touch it right here. Okay. Any question? No question? So basically, we learn programming language to be able to program in different paradigm. That's what we are learning right here, okay? And I just briefly talk over what is static program, what's object-oriented program, okay? So let's go for object-oriented program for a while. So object-oriented programming, you basically need to have a class, and class is a basic unit. And our Java right now, we just teach you a static function, calling static function. That's not object. Okay, that's not object. So object is something that you have a reference data type. And in Java, we have array, string, class. These are what AP will cover. These are non-primitive. We call it reference data type. Okay. And then we do have Boolean in the chart double. These are primitive data type. Primitive data type means that your variable A, you directly put a 3 in there. Reference data type, that means that you're pointing to somewhere else. You build more array there, and then you just keep the edges of that, okay? These are two major different types here. So circle can be a class. So this one is a object-oriented design of the circle. You have pi, you have radius. Each circle has some radius, and you get radius, get area, get parameter, and convert it to string, okay? And you have the test circle function, class, create a circle, and then get its radius, get its area. This is object-oriented way of writing program. If you write it in the non-object oriented type. Let's see if we have it, okay. Probably in the previous chapter, okay. Yeah, in previous chapter we have the circle, regular circle. Okay, let me open that previous chapter. This one, we do have a circle, and then you have radius, and then calculate the data right away. This is static function, okay. It's a purely static function. We do not have the object get involved, okay. So that's the difference between static function and object-oriented program. So this portion, I don't go any further, okay. So basically, if you have the object, you have the class, you generate your circle 1, circle 2. Each circle has its own radius. You can use that to calculate different area, different parameter, different property of the circle. Okay. Okay, that's okay. That's it can pass. Now, next one, we are going to talk about operators. So roughly, we talk about data type A plus B. A is a data type, right? Data, B is a data. And we also call them operands. Okay. And then this one, we call it operator. Okay. Plus sign, we call it operator. So because of this, you will return some value, say 3 plus 4, you get 7. So this whole thing, we call it an expression. Okay. Any questions so far? Any questions so far?
No.
Hello, no question. This is simple, right? This is simple. But we do have, say we have Boolean condition equals A less than 3. Okay, let's assume A is 4. and Boolean will store a false value, right? So not B. Not B, this one we call it unary, U-N-A-R-Y, okay, unary operator. Unary operator means that it's not like A plus B. We call it binary operator. Unary operator, we just have one operand, and the value would be the negation of the false. So not false, you get true. Okay. So we call this one unary operator. So one single operand's expression, we call it unary operator. Any questions so far? Okay, this is unary operator. There's another operator that's actually called ternary operator. So something like here you have B equals 4 less than 3, right? So if B question mark actually 1, otherwise 0, okay? Integer A equal this. So here you have a Boolean condition. Here you have an integer value. Here you have another integer value. So this operator, you have 3 operands. We call it ternary operand. 3-way operator. So question and the colon, okay? This we call it conditional statement. So if this one is true, this one will be assigned. If it's false, this 0 will be assigned to A. Any questions so far? Hi, Michael, are you okay?
Yeah.
This is written in different way in Python, okay? But we just mentioned. So there's a 1 operand operator, 2 operand operator, and 3 operand operators, okay? It's not always just 2, even though most of the cases, they are 2 operands, okay? So here we are going to teach you different operands, okay? Operators, plus, minus, times, and division and modular. Okay, plus, minus, and time, easy. The only difference, the only thing that you need to take care of is plus sign. Plus sign, you have 2 types. You have integer plus double. You become a double. Okay, you have double plus a string. You become a string. Okay, so the result is always the longer type of the 2 operands. That's the only thing you need to remember. Okay, so there's only one thing that you need to take care. More dangerous is this division. So if you have 5 divided by 3, you got 1. Because it's integer divided by integer, you got an integer. If you have 5.0 divided by 3, you got 1.66 something. Because this one is a 14-point division. This is the only thing that you need to be aware of, okay? So far, okay? And percentage means modular, okay? So you must remember something here. You have 17 divided by 3 is 5, 15, remainder 2. So this guy we write as 17 divided by 3. This is the quotient. Okay? This guy we write it as 17 take modular by 3. This is the remainder. Always remember it, okay? In this way. Any question? Any questions so far?
No.
No? No, let's see. One more thing. Okay, let's clear it. So I have an A and a B. Okay, so that's 2Q. Here you have B times Q, remainder R. So A will be equal B times Q plus R. R will be A minus B times Q. Okay, so A divided by B will be equal to Q. A divided by Q will be equal to B. Okay. A take modular by B will be equals R. A take modular by Q is also R. These are, you need to remember this in mind. Does that make sense?
Yeah.
Okay. This one right here, B or Q, doesn't matter. A equals B times Q plus R. So A divided by B, you get Q. A divided by Q, you get B. They are the same. So you take modular by B or take modular by Q, you both get R. Right? Does that make sense? Hello?
Yeah.
So remember this, okay? Okay, but there are some more typical prime number we will do in the future, okay? Now, let's look at this one. Let's look at it in one example, okay? Let's this one, okay. Let me jump to some other part. Okay, I'll come back to here later, okay? So let's go to rounding. Okay. Now question one. Question one. I have 24 candles. Okay. 5 candles a box. Now question. How many boxes can I sell? Okay, this one for Sherry. I have 24 candles, 5 candles a box. Then how many boxes I can sell?
So we want to do 24 divided by 5. So
Divide by
that's
5, you get
yeah.
what?
So that'll be 4 and the remainder of 4. 4 boxes and the remainder of 4 candles.
But I only care about how many boxes you can sell.
Oh, 4. You can only sell 4.
You can only sell 4. Okay?
Mm-hmm.
Good job. So this one you are using the division, okay? Integer division. Purely integer. You don't care about the remainder in this case. Okay? Michael, are you okay?
Yeah.
Now, let me change the problem in different way. So I don't care about how many I can sell. Okay? So now I change the problem to the different way. This is question 2 now. So question 2 is, how many boxes will be needed to store all candles? Michael, how many this time?
5 boxes
5 boxes.
to store all 24.
Yes. But if I have 20 candles, how many?
4 boxes?
4 boxes. Then how can I write a program? Let's assume that here we have asking the user to get the input, right?
Yeah.
And we need to write how many boxes needed. So let's call this one program called boxes, right?
Yeah.
Okay. So we get started with the scanner. Input equals new scanner. Okay, this one you sometimes you put file, but sometimes you put the keyboard. Keyboard is system.in. Okay. Now you
Okay.
need to do system.out.print as people. How many candles you have? Okay. Then you got the integer candles equals input the next integer. Okay. Now we continue to ask system.out.print. Okay, now we want to calculate how many boxes needed to store it, right? So we will calculate it. Now we do integer. Actually, A equals the candles. Okay, no, I'm sorry. I need to enter another thing. How many candles per box? Okay. So integer box would be equal to input next integer. So these are two numbers we read in from the user. So the condition may vary. Okay, so number one, how many box to store? Okay, so this a number of box to store would be the candles divided by the box. Okay, and then we would have integer remainder equals to candles modular by box. Okay, so this two actually is you do get the number of candles divided by box sizes. Okay, you get the number of the box to be stored. Okay, and the remaining candles. Now, key point is how many boxes you need to store is that if your remainder not equal 0, so you still have something remaining, then your box to store need to increase by 1. If equal 0, you don't need it. So this would be the answer of the this will be the answer for it. Okay, so you have the box stored, comma candles. Okay. This is system.out.print app is to clean the page. Okay, to clean the page. So let's run it. So how many candles you have? You have 24 then 5 per box, you need 5 boxes, okay? And then if you have here, let's have the 20 box, 20, and then you will have 5, you have 4 boxes. Is that okay?
Yeah.
So Michael, what is this number? What is this 4 or 5? What is this number?
Wait, what? Four boxes?
4 boxes or 5 boxes. Sometimes 20, you will get 4. 24, you will get 5. What is
Are you
this
asking?
number?
Are you asking why?
What kind of number this one is?
Oh, which number? 20?
20 or 24. You have the
An integer?
candles divided by boxes, box size. And then this one is called ceiling function. Is that okay?
Okay.
It's called ceiling function. You move to the larger number if you still have fraction.
Okay.
Does that make sense?
Yeah.
Sarah, are you okay?
Yes, I'm okay.
Ceiling function, they really has a mesh.co function you can do. You can use. There is a function called mesh. But if you don't use the mesh.co ceiling function, you use such an operator. Divide it and take the remainder and then +1. You will get a ceiling function. Okay. And the other one, actually is the one that how many bucks you can sell, right? How many boxes you sell? That one is called flow function. Okay. So let me create a class called boxes to sell. I'm sorry. Okay, this one was changed to here and then how many boxes. So we would like to calculate how many boxes you can sell. You just create a box to sell, and this one, let's call it box to sell. This one, so these boxes can be sold for this many candles. Okay. So this one would get the flow function. Flow function, you do this, or you do quantization with integer. That will also get the flow function. Okay. Okay, you can only sell 4 boxes with it. This is called flow function. When you have some A divided by B, you write it in this way. That's called flow function. Okay. Again, there's another function in mesh class. It's called mesh.flow. And put the double value there. It will convert to an integer. Okay. Any question? Any question? No, this one is
No.
too rounding, okay? Okay, this one we do rounding to 10. I have certain boxes. This one is a coding back problem, okay? The fixed 10 problem, the fixed 20 problem, big 10 problem, right? I have like 15 bucks. I will round it to 20. I have 14 bucks. I will actually round into 10. So this function is rounded to nearby 10. Okay, so we do have a number of boxes, and then we don't need it. Okay, and we are going to do calculation. So I'm going to do it like this one. Okay, so many candles will be rounded to how many pence? Okay. So if we have 14, you round it to 10. 15, you round it to 20. Okay, you round it to nearby 10. So you have 10, 20, 30, you have 14 or less, you round it to here. You have 5 or more, you round it to here. Okay, you have 15 to 24, you round it to here. Okay, you have 25 to 34, you round it to 30. Okay, now how can you do it? Right? This one is a coding bed problem. So Shara, you remember how to do it?
I don't know how to do it like the most efficient way, but
Mhm.
I know how to solve.
I know how you solve, but do you remember what we talk about before?
No.
No. Anyone still remember? Some of you haven't touched the problem yet, okay? But Sherry, do you remember?
I'm not very sure.
Let's look at a function. Okay, let's have the x and y. Okay, let's assume y equals quantization of the x. So if you are 0, you get 0. If you are 0.9999, you get 0. Okay, so this one from 0 to 1, not including 1, you get 0. Right? From 1 to 2, but not including 2, you get 1. This is the function of this flow function. Right?
Yeah.
Okay. And many of you would do honor pre-calculus this year. So let's assume this chart, if you move it to the left by 0.5, what will happen? So we have a new x and new y. So the new x 0.499 will round it to 0. And then 0.5 will round it to 1. So if you shift the black one to the left by 0.5, you will got the what? You got the rounding effect, the generic rounding effect. Is that okay? The rounding you know, right? Is that okay? Hello? Is that okay?
Yeah.
So this one that you have the green y be equal to. I'm sorry. Let me actually erase it. Your red y will be the same as your red y. Okay. and then your red x would be your red x minus 5, right? At 0.5. Is that okay? Is that okay?
Yeah.
So your red y would be equals y, and then your red x should be your red x plus 0.5, right? Put it in here. So your red y will be equal to integer your red x plus 0.5. That's it. That you finish the translation, moving the grid to the left by 0.5. This will do the rounding. See how I do it? Any transformation can use this big X, big Y method to do it. Okay, no matter it's a rotation or it's a translation or anything. You find out the relationship of new X and new Y, put it back to the original. Original equation is the black one. You substitute it by the new X, new Y. The equation still hold. Then you would get the equation for the red X and red Y. Now do rounding. Is that okay? Hello? So to be sure, let's look at this one. Let's look at your big Y will be equal to big X plus 0.5. So that's just when X equals 0.444999, okay? This one should be 0.9999. So it will be rounded to 0 to the Y. If this X equals 0.50001, then this one 0x plus 0.5 will be 1.00001. It will be rounded to 1. So this would be the rounding function. Of course, you do have the mesh rounding function for any x. You can do rounding use that. But mathematically, if you don't have a rounding function you can use, you will need to use this formula. Plus 0.5, you will round it to your nearby integer. Does that make sense? Does that make sense?
Yeah.
Sarah, are you okay?
Yes, I'm okay.
How about Leon, are you okay? Hi, Leon, are you okay?
Yeah.
If you have question, you must ask, okay? You must ask.
Yeah. Okay.
One thing I want to emphasize that this one, the one you are looking at right now, this equation is tested in AP many times. I would say at least 3 to 5 times before in AP history. Okay? I'm talking about it not for fun, okay? Not for fun. They teach you how to do this in the AP, okay? So later when you do practice set, you'll find out this equation, okay? So to be short, let me make it shorter and easier to understand. A value you want to do rounding using the normal rounding way, you just plus 0.5, you will round it to the value you want, okay? So now you want to round it to your nearby 10, right? You have an integer you want to round to the nearby 10. So this value plus 5 divided by, this is an integer, divided by 10. So you will have a 15, you will become 1.5, right? And then this thing, I'm sorry, you become actually 1.5, and you'll be rounded to 1. I'm sorry. Let me erase it. Okay, this is no good. So this if x is 15, you will have the 20 divided by 10. You will get 2.0. You round it to 2. Okay, so this one you times 10. You will get 20. Divide by 10, integer division, and then times 10. You plus 5 first. Does that make sense? Does that make sense?
Yeah.
Okay. So if you have 14 plus 5, you get 19. 19 divided by 10, you get 1. 1 times 10, you go back to 10. So 15 go to 20. 14 go back to 10 by this equation. Okay? That's the solution we need to have here. Okay? So rounded to the nearby 10. Okay? So here we would have the integer tens will be equal to the candles divided by 10 times 10. That's it. Theory is very difficult, but the problem is pretty easy. Usually like that, okay? If you understand, it's easy. So 24, you round it to 20, okay? One more time. You have 25, you round it to, I'm sorry, 25, you round it to 20 as well. This one, I forget to plus 5, okay? I'm sorry. Very, very sorry. I forget to plus 5, sorry. So again, 24, you get 20. 25, you get 30. Okay, this is very, very important, okay? Very, very important. Okay? I'm talking about this modular and division, and I'm teaching you the tougher part, okay? The easy part, I'm not going to touch it today. So I'm talking about the tougher part. Now, next one. Next one, we do have a few problems before. So we have a string length of some number n, right? 3 later a section. We do for loop. So we stop here. 3 a section, we do rotation. A, B, C become B, C, A, okay? Remember this problem, right? So how can we find out how many sets we can rotate? Remember this problem? Some of you may do this one in the coding book. This one, it will be the n total string length divided by 3. Okay, that's the number of sets you can have. So right here, let's assume this is a 13. Okay, you will get 13 divided, you'll get 4, right? For 4 sets. But what is the index right here? The next one that doesn't include, that would be n divided by 3 times 3. Is that okay?
Yeah.
Yeah. Remember this, okay? This one similar to the problem, but you have to remember this, okay? This one we did it in coding back before. Sarah, is that okay?
Yes.
I'm trying to review in this division for you. Make sure you do remember it, okay? In programming, these are very important. Okay, so this one is something that you need to remember. If you want to know how many sets you have, you divide by the integer, you will have how many sets there. And then the total index you have is the number of sets times the 3. You go back to the next one that's available after in. Okay? Okay, there's another problem, okay? Another problem that actually is a MAC3 problem that I usually use a 28 to do it, right? So 5, every nickel is a 5, right? Every nickel is 5. Totally, you have a goal, right? So you don't know how many nickel you have, how many penny you have. This one's big, this one is small, right? First thing you need to know is that how many penny can be paid by the nickels. So the maximum number of the nickels you can pay is actually 28 divided by 5. The goal divided by 5. That's the maximum number of the penny you can pay by the nickels. But you may not have that many nickels. So how many nickels you really can use is the big one, take a minimum with that number. If you pick greater than goal divided by 5, then you have to use goal divided by 5 because that's the maximum of the penny you can use. If your goal divided by 5 bigger than the big, then you can only use the amount of the penny that you have. So it's a minimum between these two numbers. That's the number of the nickel that you can use. And the rest of them you need to take care by your pennies, either here or here. Okay? Remember this one? So today I'm trying to teach you more advanced integers. Okay? Must remember them. Okay? Must remember them. These are very important. Before you do coding, you must figure out which is the right index and the range of the index you can use. Any questions so far? Any questions so far? Hello?
No.
One more thing, okay? One more thing. You do have an array. The length is n. If this one is odd number, that's when n equals 5, okay? So the middle one will be n divided by 2, right? If you have the even number, this middle one will be equals 2, equals 3, okay? 0, 1, 2, 3, 4, 5. So the middle one is the middle on the right. Remember this, okay? This you need to always remember these kind of things because we often deal with the middle a lot. Does that make sense? That's one system, okay? That's one system. So remember, if we use n, the length of the array or the length of the string divided by 2, the middle one, if odd number, you'll be dead middle. If the middle one to the divide by 2, the length divided by 2, for the even one, it will be the middle on the right. Okay? That's one system. There is another system. We have odd number. This one's 0, 1, 2, 3, 4. So this we call it low. This we call it high. So the middle one equals half of the low plus high. In odd number, this middle one is right here because it's actually 2 plus 4 divided by 2. I'm sorry, 0 plus 4 divided by 2. You got 2. If it's an even number, totally 6 numbers. So your low is actually equal 0. High is 5. right? So your middle number is actually equals low plus high divided by 2. That would be 0 plus 5 divided by 2. You still get 2. But this middle number would be the middle on the left. So this using the n divided by 2 and low plus high divided by 2, you get different middle one. But you need to know about which way you do and which middle you found. Does that make sense? And this is often used in your binary search. The second one is used in binary search and merge sort. Okay, we will see that later. But remember these two index scheme. Any questions so far? Any questions so far?
No.
No, we are done with this stupid indexing and modular. Okay, a lot of things you need to remember. After class, you may need to take notes. Okay, unless you are super good in this. So we do touch the so-called the floor function. Okay, this one is a ceiling function and floor function. Okay, and also rounding function. Okay, remember that we talked about it today. Okay, now there's another one. Oh, okay, I still miss one. There's another problem. Okay, now we want to truncate some data. So let's assume we have a number 1, 2.3, 4, 5, 6. I want to round it to this digit. Not by printf, but I want to round the number to here. So I will just store the data as 1, 2.34. How can I do it? Rounding by 2 digits. Okay. So let's assume this number is actually called D. So integer D equal this. Okay. I want to truncate over here. So what I will do is actually do D, okay, times 100. This number will become 1, 2, 3, 4 point. I'm sorry, this should be a double value. 0.56. Right? Then this whole thing do quantize. Then it will become 1, 2, 3, 4. And then this thing I divide it by 100.0. Cannot divide by 100. Okay, divide by 100, it become integer. So that one after this, it become 12.34. Does that make sense? This is get rid of the two numbers. If you do rounding, what should you do? If you don't rounding here, if you do rounding not really get rid of this. If you do rounding right here, it's just plus 0.5. Is that okay? You round it to 1, 2, 3, 5. Is that okay? Hello?
Yeah.
Do rounding, it's just part of that. This become a rounding function in here. Okay? Okay, let's do this one in program, okay? So don't overdo these simple integers. These are not that easy, okay? This one called round to 2 places. Okay, so I'm called round to 2 places. and 100 and then push back, okay, by 100. Okay, and next one, double y equals integer e times 100 plus 0.5 divided by 100.0. Remember the technique, okay? Time and then divide, but you need to be aware of what places you are and where you do truncation. Oh, sorry. This one should be y, okay? And put in x, you still see the same x. Rounding to two places and truncate to two places, they are different results. Any question here? Any question here? Hello?
No.
No. Next one, we are going to look at go back to look at the plus sign. This multiplied by augmented, I think everybody know, okay? I'm going to spend more time on the increment, decrement, okay? This one, I think everyone know what they are. So we do have a post-increment and pre-increment, okay? So let's assume that originally I equals 1, j equals, so integer j equals plus I, and then originally I equals 1, okay? This one is you increase, then assign value. So originally you are 1, you increase to 2, so j will become 2 after the operation. I will become 2 as well. It's called pre-increment, okay? Plus I, increase first, then get the value, okay? If you do have an integer j equals I plus I equals 1 initially, this one get the value, so 1 assigned to j becomes 1. Then it increases, so I becomes 2 at the end. Is that okay? So far, okay? This is the post-increment and pre-increment. You probably only get tested by this post-increment or decrement, okay? It's also possible that you decrease, okay? And when are you going to use this? When are you going to use this? Okay, let's look at pointers. This one, I think we also do it sometime in coding back, okay? So public static, okay, integer array A equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, let's assume that we do have an array like that. It's very simple, okay? Now we do have Actually this one static. Okay, let's call it integer array, sub array. So we want to get a sub array. What sub array? We do get this array A, and we will get the array from the starting index to the ending index. Okay? Is that okay? Hello? We try to get started for the starting index to the ending index, by ending index not included. So we'll copy this one to a new array. Is that okay? Subarray. Hello? Is that okay? Right. How comes no response?
Yeah.
Sherry, are you okay?
Yes.
We don't have a subarray in Java, right? But let's create a subarray. So you're going to get this one. Number one, you need to know about how long you have. So let's assume you are going to do these. Okay, 5 to 10, but not including 10. Okay. So number of the element is you will need to create a new array. Let's call it B. Okay. It will be actually new integer. How long? It will be the end minus start. Okay. So if actually end less than start. Okay. Then we will return. Okay, new integer array. Curly brace. So this one will return. I'm sorry, don't do this. Okay, let's do integer array 0. You return an empty array. Okay. Now, if not empty, okay, empty we return empty array. That's okay. If not empty, we'll return B. Right. So we start to do copying the data from here to here, right? But not including this one. So we will do this. We'll do for integer I equals 0, I equals star, I less than end, I increase. Okay. And here we will use integer P equals 0. So B is traversed by P every time it increases by 1 after the operation. So initially your new array okay, 0, 1, 2, 3, 4. P equals 0, you put a 5 in there. P equals 1, you put a 6 in there, right? So you started from start, then you put the A's I assigning to the P plus B's a P plus plus. So let's assume that you first get the index 5. Your I is index 5. Your P is 0. Before you increase, you put a 5 over here. Then P move from 0 to 1. So every time you increase by 1, so you don't need to worry about P and B. It's just counting over the P's direction. Keep going. This is how we use the pointer P. And your I gets started from I, it keep running until it hit the end. Okay? And we also need to take care of that, make sure that star cannot be less than 0. Okay, so here also. And actually greater or equal to 8 or less. Okay, this you cannot. No, equal okay, greater not okay. Okay. Does that make sense? That's the subarray. You can use this one to get whatever subarray you want to have. Okay. So this is the use of the A++, P++, okay? Any question?
No.
So plus is openly used when it used for an index that keep moving, okay? So we actually put the sub A array and starting from 5, ending at the 10, we get a sub array, okay? Just like a substring, okay? Just like substring, but we do not have a substring in Java array, okay? So this is the way you do it, okay? Okay? There are several different ways to do it, but in the future, if we have chance, we will teach you, okay? So right here, let me change it from 3 to 12. There are several different ways to use this pointer in this way, okay? The simple division or those kind of things, I'm not going to waste my time to talk about it, okay? I just teach you more advanced stuff. Other things, you need to study the material, okay? This expression, I think you can convert it. Everyone has some programming background, so I don't worry about it. And its augmented assignment is one thing is that you need to remember plus equal is increased by, minus equal is decreased by, one is multiplied by, one divided by, one is multiplied, okay? I think everyone has a background to understand this, so I'm not going to worry about it. This diagram is very important. When you have two operand, then the final data type will be the longer type. Okay? Will be the longer type. So if you have one integer plus a double, you become double type. You have a short plus a integer, you become integer. You have a chart plus a integer, you become an integer. Okay? This is what this chart is. But this one, it actually do not have a string. String is longer than double. Okay? Any question? Automatic conversion. But if you try to assign a longer format to a shorter format, let's assume that you do have a double D equals 3.4. You try to assign D to integer I. This is not okay. You have to do it as integer I equals converting the double to integer. You must quantize it. If you have a longer form, you want to convert it to shorter form. Okay? Any question? Any question?
No.
So after class, you must practice the different operand and copy of the array, okay? Keep coding that you will learn it. Now we have the remaining time. I'm going to work on this one, display current time from system, okay? So this one, we are going to display the getting the computer time and show it as a clock, okay? And this is related to our operand. So let's call it class, this class as current time, okay? Okay. So let's assume that we actually have a number called total seconds. We want to convert it to how many hour, how many minute, how many seconds. Okay. So integer hour should be equal to seconds divided by 3600. Is that okay? First, let's actually convert it to days. So that would be seconds, okay, divided by this many seconds, okay? Is that okay? And then your seconds will be equal to this total seconds divided 10 modular by so far, okay? You have so many seconds, you want to know about how many days they are, you divide it by A6400. That's actually 60 times 60 times 24. Okay? And then you have the remaining seconds so much. Then you use that to calculate hour. Then you will have the remaining seconds of the 3600. Okay, this one is the seconds in an hour. Okay, then you do minutes will be equal to seconds divided by 60. That will be, and then your seconds will be equals, will be 10 modular by 60. This one will be the seconds in minutes. Okay. So we got the hour, minutes, and second now. So we do system.out.printline, printf. Okay. So break it, percentage 0.2d, 0.02d, and then percentage 0.2d, colon, percentage 0.2d. Okay. And then /n, and then you have the hours, minutes, and the seconds. So far, okay.
Yeah.
Okay, so you got certain hour, millisecond by doing this. Now we want to grab the time from the system. Okay, so we will have a long integer called timestamp. This timestamp will be equal to system that current time minutes. Okay, there's a function called this. Let me check. Okay, yes. So that actually is the current time in minutes. And then we will convert it to a integer that's called seconds. So this is a timestamp. Okay, divided by 1000. This one is actually the system time. The system time we grab from our system. Okay. So that's the system time from computer. We divide by 1000, and then we convert it to an integer. This one will be a long data, but we convert it to integer. That would be the how many second since, okay, this season time immediately will be from what? From January 1st, 1970. We don't care about a day, so we would have the remaining. So this is a second is okay. But here one problem is like this total second will be the Greenwich time in England. So we need to minus 7 hours. So this is 7, let's call it the time zone. Let's call it as a minus 7. That's a Los Angeles Pacific Daylight Time. If not daylight time, you need to use a -8, okay? So this one you -7, okay, times 3600. So this one is compile and run. This one's now 4:47:1. Hit another one. 4 o'clock 47:8. This is the current computer time. Okay. To do this, make sure this one keep running. You do while true. That will become a clock. Oh, this one going too fast, okay? Going too fast, not a problem. Let me stop it. So let me let the program sleep for 1 second every time. So let's import java.len/thread. Okay. So right here, after we display something, we do thread sleep for 1 second. Okay. One second is 1,000 minutes. Oh, this one was throw exceptions. Throws exceptions. Okay. I'm just showing you how to do a clock design. Is that okay? Hello?
Yeah.
Okay. And we want to convert it to 12-hour system. So right here, let's do this. Hour modular by 12. Okay, convert it to AM, PM format. This one is forever, it's an infinite loop. So you want to stop, you click on the button here, okay? Then you run it, you get the right timing. Okay? So this one, a program purely write down by division and the modular. A clock, system clock, the same as the one that you found on the button. Okay? Any question?
No.
Okay, no question. That's it for today. Okay, work hard. Okay.
Okay. Thank you.
Bye bye. Bye bye now. Bye bye.
Okay, thank you.
Bye bye.
Bye.